Okay, I think we're going to get started now. I think most of the people are in. Oh, we're still getting some new people join us, so I'll wait it for a second. All right, I think we're slowing up the number of people joining, so I'm going to get started. Welcome to this webinar. It's from and about the Edmonton Regional Hydrogen Hub. There are a lot of individuals on the webinar today, so we don't really have a way to ask everybody to introduce themselves. So what I would like you to do is to go to the bottom of your Zoom box here and click on the chat function and introduce yourself to the others on the call, and maybe tell us where you're coming and calling in from today. Are you calling in from the Edmonton region or some other parts of Canada? So please introduce yourself to everybody, and that will be a good opportunity for people to understand who else is on the call and who you are. And the other thing is if you also see at the bottom of your screen the question and answer button, a Q&A. If you have any questions that you would like to ask to the presentation speakers today, the speaker, which is going to be Mark Lee Wilson, I would ask you to enter it into the question and answer, and I'll be tapping into that during the presentation in order to to feed the questions through to Mark. My name is David Lazell. I'm the Energy Systems Architect with the Transition Accelerator. We're a pan-Canadian nonprofit charity that is working to speed the transition to zero-emission energy systems across Canada. We have a particular focus on the shift to very low-carbon electricity and hydrogen as energy carriers that will support and advance economic development and the quality of life of Canadians. I'm wondering, Mark, if I could get you to put on your screen and do a screen share for everyone, and I'll use it to introduce the Edmonton Regional Hydrogen Hub. Now, the Transition Accelerator is pleased to have a role in the establishment and the running of the Edmonton Region Hydrogen Hub. And it is an alliance of leaders from federal and provincial and municipal governments. You'll see the federal government logos on the left of this chart. On the bottom of the chart, you see a number of the municipalities that are engaged in supporting the Edmonton Region Hydrogen Hub. We also involve a number of First Nations groups, and you can see that on those logos on the right, and economic development organizations as well as academics at universities around that are feeding in providing valuable insights and information into the activities of the hub. What we're doing is these various groups are working together to build a vibrant new energy system around hydrogen as a zero-emission fuel to support and advance both the economy and the environment of the region, the province, and all Canada. Now, before introducing our speaker, what I'd like to do is respectfully acknowledge that the Edmonton region we are talking about today is located in Treaty 6 territory. This is the traditional gathering place for diverse Indigenous peoples, including the Cree, the Blackfoot, the Métis, the Nakota Sioux, the Iroquois, the Dene, the Ojibwe, Saulteaux, and the Anishinaabe, as well as the Inuit. Now, to give us an update on the progress and current activities of the Edmonton Region Hydrogen Hub since its inception, which was only about 11 months ago or 11 and a half months ago, what I'd like to do is to introduce Mark Lee Wilson. He's the Hydrogen Hub lead for the Edmonton Regional Hydrogen Hub. Mark is a mechanical engineer and a certified energy manager. He has an MBA that has focused on economics, finance, and technology commercialization. He has 20 years of experience in the energy industry, working on innovation, product development, energy management, manufacturing, and business management. Well, innovation director and shareholder of a private manufacturing company that he launched new product lines, business lines, and collaborations to commercialize innovations, including several patented products. This was done on a foundation of operations and design engineering experience that formed a broad understanding of manufacturing, engineering, and supply chain, rooted in lean manufacturing and process thinking. Mark's passion for energy and systems led him to the role of the Hydrogen Hub lead in the Edmonton Regional Hydrogen Hub, and working also with the Transition Accelerator. Within this organization, he's really helping to build pathways to an economically sustainable hydrogen economy that is compatible with net zero energy systems of the future. So Mark, would you please take it away and tell us what's happening and what has happened in the Edmonton Hydrogen Hub over the past year. Thank you.
Sure. Thanks, David, and good afternoon, everybody. Thanks for the kind intro. Welcome, everybody. So I'm here to reflect, as David mentioned, on the past year or so since the hub launched. I'll highlight our mandate, some of the activities that we've undergone, what we've learned over the past year, and how we're applying some of these learnings going forward. And when I say hub or we, as I'm talking, I really do mean all of those organizations that David had mentioned, as they've all contributed in some way towards the different pieces of the hub work. One more housekeeping note: we will make these slides and a recording of this webinar available on our website, which is erh2.ca. But first, some quick context. Why are we talking about hydrogen? Well, if you've been to our past talks, and I'm sure many of you have, you'll recognize these two pie charts. We like to open up with all of them. On the left, what we're depicting is our existing energy system in Canada. And then on the right is a possible future energy system that is compatible with net zero. So this is important because the world is moving this way, and over 90% of global GDP in the world has some net zero goal of some kind. So we have a choice. We can either leverage our considerable strengths and advantages when it comes to the transition to come out ahead on all fronts: environmental, social, economic, or we can sit on our hands and wait until we're forced into reshaping our energy system after it becomes too costly to do nothing. So if you believe me that it's important to transition our energy system to be compatible with this future, you'll notice two big trends on the right. One is electrification. We can expect doubling or tripling of the electrical grid. This gets a lot of media attention and a lot of discussion in energy transition circles. And that's for good reason. Electricity can be a low or no carbon energy carrier that can be conveniently substituted in many of our end use applications, such as personal transport, vehicles and passenger cars. But the second one is, you can see hydrogen is sort of the new actor on the stage. And there's a worldwide consensus to play a role in a net zero energy future in areas that are uneconomical or operationally difficult to electrify, such as heavy duty transportation, some heavy industry, some heating applications, and electricity generation. But hydrogen use as a fuel for these industries is new, and the value chain to make, deliver, store, and use the hydrogen for these sectors does not exist, and it needs to be built, or existing systems somehow repurposed. And I don't mean just physical systems, I mean business systems, workforces, supply chains, and others, many other factors that will need to adapt. Moreover, each part of the value chain has distinct risks and challenges and opportunities. So building this new value chain is central to the problem, the central problem that the hub was formed to address. And a hub approach really is a way to have strategic conversations with stakeholders along the value chain, creating a setting for organizations to collaborate and solve these problems. So if we picture a value chain, it might look something like this, which is likely also familiar to many of you in the audience. Left to right, we're showing different ways of producing hydrogen, distributing hydrogen, storing hydrogen, and then finally end uses of hydrogen. And if you think of the organizations and stakeholders along the value chain, the areas in blue are made up of established entities for the most part, and they're already working hard to further develop sectors of the value chain. So really, when we talk about the hub, a lot of our focus is on the areas in green. And that's because these are new. We need to find ways to create new demand and establish new distribution channels for hydrogen. And because it's new, the way that this value chain is constructed is important because that's what will determine the overall cost and ultimately the economic viability of the value chain. So that's why the hub approach. So I want to get a little bit into the weeds about how the hub operates, what we actually have been doing to date. So first, we need to think about what the hub needs to do. And really fundamentally, what we need to do is build market confidence. And it's market confidence on both the supply side, but also on the demand side. Both of those need each other to exist, and we need to build enough confidence for organizations to invest in the value chain. So really, this means addressing the risks and the business needs, such as economics is an obvious business need, but there's also a lot of non-economic business needs. And we need to do this for all the stakeholders along the value chain. So how we do this and what we've been doing for the past year is through a combination of techno-economic analyses and strategic engagement with stakeholders. And in the end, it's a collaborative process that is leading to higher confidence in investment decisions. So the way the hub is actually structured, we have a leadership team as part of it, and these are the mayors and the chiefs of the surrounding municipalities and First Nations. And really having them as part of the hub is great because they're tuned into sort of the nuanced characteristics of the region. We also have a management team which consists of representatives from the 3 levels of government, the other funding partners for the hub, so municipal, provincial, federal, as well as NGOs like the Transition Accelerator and economic development organizations like the Alberta Industrial Heartland, Edmonton Global, and the Alberta Indigenous Opportunities Corporation. And really, it's at this level that they provide tactical awareness and organizational resources that can be coordinated, within their individual organization mandates. And then we have all these circles underneath here, which we call the engagement teams or the action teams. So what we do is we map these teams back to sections of the value chain. So for example, the supply side, we've formed this team around what we call the market sounding process. And what this was a formal process where we set up many months of meetings over the spring and summer of last year, engaging with industry on the supply side on a one-on-one basis. And then commercial and municipal fleets team consists of private fleet owners and operators, the Alberta Motor Transport Association, and municipal fleets, Strathcona County and Edmonton, the city of Edmonton. And we have ongoing regular engagement and meetings with these groups and these organizations, and we've been doing that since about February or so of last year. Similarly, we have a heat and power working group that was set up later towards the end of last year and have been convening regularly. So it's really within these teams that we're developing and executing strategy to launch initiatives, advance progress, and identify the barriers that we need to overcome to fully leverage the opportunities. So we spent last year or so setting up this structure, engaging with stakeholders, and performing techno-economic analyses, which I'll talk about a bit later. In total, we've engaged over 100 companies that have been connected into the hub, which has provided the opportunity to share a lot of the techno-economic modeling and test some of the assumptions of the modeling and some of the results for feasibility, fit, ultimately making the analysis more robust and more credible. So beyond the teams, the hub has also been active in hosting strategic webinars. You can see sort of a list of the webinars that we've undertaken and their dates. They are available archived on our website. So these are a one-time open access type of events, similar to today's webinar. And very, very early on, for example, we recognized the need to shed some light on international market potential. So we hosted a short series of export webinars that highlighted China, Korea, and Japan as potential markets. Again, this was in very close collaboration with hub organization partners. Edmonton Global and Alberta Industrial Heartland were key players, for example, in that initiative. And although the market sounding process I mentioned was a one-time process, so it spanned from May till November, we do have ongoing informal engagement with a number of the companies on the supply side that are actively exploring investment opportunities in hydrogen. We also hosted a few online workshops. One was a fueling station workshop series, and one was a hydrogen diesel dual fuel commercialization program that recently closed. I'll talk a little bit more about the outcomes of that later. These types of engagement activities were one time, but they're invites or opt-in format. So the way we engaged companies there was through our collective networks. We would reach out and do personal invites to companies, or on social media, we would reach out and invite for participation as well. And then finally, the fleets and the heat and power groups, as I said, they're still part of an ongoing engagement. And there's a number of active organizations exploring opportunities within those groups. So if you remember kind of the two pieces of activity, one was engagement, the other was TechnoEconomic Analysis. So in parallel to that, we've been sort of beavering away hard at a number of TechnoEconomic Analyses. The first ones released in 2020 really helped kick this whole thing off, but we've continued that work and we've really built upon that initial analysis throughout 2021. The nice thing about doing this in parallel with the market sounding and the engagement is that we were able to, as I mentioned, share real-time results through webinars and other engagement activities, even though formal reports weren't ready. But we did have a few important reports that were published towards the end of last year. A technical brief on compression of hydrogen and another one on the techno-economics of pipelines. These standalone documents are quite interesting and important, and we do have a webinar coming up on March 10th that will unpack them a little bit more, but they also are feeding into additional reports. Sorry, I'll back up 1 second. Base case module and modules, for example, this is a series of analysis that we undertook over the past year or so. And it's not formalized into a report, but it is going on to inform a number of reports that we'll be releasing. But really what it has done is informed our understanding of the region. And I'll have a little bit more on that later as well. So here's an example of some upcoming reports that we'll be releasing early mid this year. Really, again, built on, to use the old adage of built on the shoulder of giants. These reports, a lot of them build on the learnings from past reports and past analysis. So that's a lot about the activities that we've been up to for the past year or so. I'm gonna, just take a quick breath and switch gears now, and I really want to talk about some of the key results and the insights that we've gained in that past year. Now that you know sort of what we've been up to. And you can find a lot of this information buried in our webinars and some of the blogs, but here are some of the highlights, I suppose. So one of the major initiatives, as I mentioned, was market sounding. And there were a lot of nuanced insights in addition to what you see on the screen here that we did learn. But think of these as the big meaty sort of aha moments that are worth touching on individually. These are key principles really that we've identified that need to be in place for the successful build out of a hydrogen value chain. So first is this defined and agreed upon vision of a future scenario. So there's this word base case again. So what we've done is we've started defining a base case, which is a scenario model for 2032. So we're looking about 10 years out. And why that's important is it gives us the ability to define an endpoint, which then allows us to start exploring possible pathways of how to get there. And then building on that, what are some first potential steps that we can take? So we need to understand the potential in the region before we can start thinking about economic viability and scale. And the way to understand that potential is to build this vision of the future economy. How big is it? What's the possible amount of hydrogen demand? How many vehicles? How many pipelines? How much production? All of that is really important foundational information. So the second principle is economic viability. So once we can understand the scale, we can start thinking about, well, what are the costs now going to be, and how can we make it economic? There's lots of tips there on ensuring economic viability. I keep talking about scale and how important getting to scale is, investing in CapEx for efficiencies, investing in areas of the value chain that need the most support, and also where there's shared infrastructure like pipelines and compressors and things like that. And it's also super important to create demand. Most of the companies, if not all of the companies that we talked to, their number one question for us was, can you help create demand? The production will follow if there's demand, sort of thing. If there's one thing that we're good at in this region, in all of Alberta, it's producing energy and delivering projects that produce energy. So it's an expertise that's already in the region. So what they keep asking us, and what we keep finding, is that what we really need to do is create demand. So it makes sense to look at the economics of where it might be easiest to create demand. The transportation sector offers a place to start because in the current market, hydrogen really has the best chance of being economically viable when compared to diesel, for example, but also very close to economically viable versus the status quo is using pure hydrogen in combined heat and power applications. Think, really large buildings that are energy hungry, rec centers, large industrial or commercial buildings. And there's a natural complement between these two sectors for low-cost fueling stations and large facilities to be connected to a production source with a pipeline to deliver the hydrogen. This is the idea of harnessing the complementary cross-sectorial demand for hydrogen. Blending is also an important economic lever to help support the construction of pipelines. So these are all sectors that we're looking at closely. We're looking at the economics and the feasibility of what are the barriers that need to be overcome to sort of get these demand sectors off the ground. At the same time, we do need to recognize that it isn't all about economics. Solutions across the value chain need to work for each sector. An easy example of that is the transportation sector. Sure, the economics of the fuel costs need to work, but so do the economics of the total cost of ownership of the vehicle. But there's also non-economic factors that have to be considered, like operational constraints, operational flexibility, the standardization of their maintenance, things like that are all sort of non-economic needs and risks that need to be addressed. And they're unique at each sector of the value chain. What's good for a trucking company might not necessarily be good for a transit fleet, for example. So the second big initiative last year was base case modeling. So again, what is base case? So we've called base case 2032 is a description of a future optimized self-sustaining hydrogen economy created through data analysis and using market sounding as a way to test and validate the assumptions and results. And it's the idea, again, of beginning with a described future that is clear and credible. And then in that way, we can start defining possible pathways to get there. So collecting data, organizing it, arranging it, and then starting to tell stories about it. So where we began is we started looking at important assets in the region, private fleet bases, municipal fleet bases, fueling stations, looking at large buildings, where are the natural gas blending gates, power generation, where are the demand sinks, and also what are existing and potential and announced hydrogen supply and hydrogen infrastructure. And then we engaged with most of, or if not all of, the asset owners that we could identify, seeking their endorsement of the base case idea through the working groups, through market sounding, through engagement, and trying to get a sense of their level of ambition and their level of willingness to move down this path. And what we found is that the domestic market in the region is sizable, and it does offer a unique opportunity to build out a hydrogen value chain, which can form the foundation of additional economic activities such as the engineering, construction, manufacturing, R&D, and of course exports as well. For context, by 2032, the transportation module shows about 10% of the provincial truck fleet converted over to fuel cell vehicles, which aligns completely with the provincial hydrogen roadmap that was released later after our first iteration of the base case. The model is inevitably inaccurate at this point. We continue to refine it. I know these numbers that I have that I'm showing you right now, for example, aren't the latest ones. There are updated models that are refining these numbers. But what they do though is they serve to show the order of magnitude and the scale of the opportunity that we're looking at. We should have some updated outputs, later spring or sometime later this year. But again, it's the numbers themselves will continually be changing as we refine our inputs and our assumptions. But importantly, probably more importantly, what the model allows us to do is break down in a granular fashion what is the demand and what is the required infrastructure build out, almost year by year, or at least sequentially, to help us plan what we can and should be doing in the coming years. So if we extend this idea of we have an end goal, we have a reasonable pathway from now until then, we can break down the model into, okay, well, what do we actually need to do in a stepwise manner, and how can we conceptualize these into actionable and investable projects? So if you think about what an implementation pathway might look like, it might be something like this. We have a list of projects that are loosely sequenced and loosely tied together. And this isn't meant to be a prescriptive list by any means. This is going to be something that is iterated, and ultimately it will be the level of leadership of the organizations that are going to be doing the investment that will determine the sequence of a build out of projects that can get us to this 2032 scenario. And it's those organizations as well that will determine the scope and the purpose of the projects. But really what we have now is a place and a method to start from. And if you remember, one of the purposes of the hub is to create this platform or this setting or this forum where this type of discussion can happen. And you could see from the legend, there's a lot of activity already on some of the early projects. Some are funded, some are partially funded, funding has been applied for, and some are just in conceptual sort of discussion stages. But the real point here is thinking about how the projects fit in with each other, both in terms of sequencing, but also in terms of what are they accomplishing? What needs and risks are they addressing? What sectors of the value chain are they addressing? And to the sequencing part is what future steps will they unlock? There's projects here that can't happen without some of the previous projects, and there's projects that although the scope of them is narrow, and I'll talk about some of them in a minute here, but the scope is narrow, the knock-on effects of the projects are broader and really enabling additional projects. So a little bit of a deeper dive into some of these projects. These are existing ones that have launched that are important to the hub. Most of them have direct or indirect links to the hub. And I'll just kind of walk through a few of them. The AZTEC project, number one, it's one of the higher profile projects for sure. And it was actually launched in 2019, sort of predating the hub, but sort of with the same thought process and the same train of thought, certainly as the hub. And really what it's about is proving out existing technology in an operational environment. And you'll see the Suncor logo, for example, is in there. There's sort of another hidden benefit of this project as well, is it's proving out the technical and logistical aspects of hydrogen fueling, right down to the safety protocols and the operator experience of fueling with hydrogen. The ATCO gas blending project, this is important. Blending is a really important piece that we need to figure out as well. Now, you might hear pushback from time to time on, is blending really an effective way to decarbonize the natural gas utility system? I would argue that argument, I'd argue that that's missing the point. So if you the idea of the projects is to build a new value chain. So the scope of the project, again, has purpose beyond the immediate scope of what's actually happening. Sure, ATCO is going to blend hydrogen into a small portion of the Fort Saskatchewan utility system, but really what they're doing opening the door to incentivize the construction of critical infrastructure such as pipelines and production facilities. It's not necessarily about decarbonizing that 5% blend of hydrogen into natural gas. But even this project isn't big enough to do that, to incentivize the build out. So really it's a pilot project. So what the benefits of this project is, it's uncovering critical barriers such as regulatory hurdles and technical feasibilities. Beyond this project, we'll still need a larger project that gets into the economics of blending. This one is really just uncovering, like I said, those barriers. The bus pod project, the AZIT, we're not quite sure how to pronounce it. I pronounce it AZIT, Alberta Zero Emission Hydrogen Transit Bus. So this is similar to, both projects, number 1 and number 2 there, where it's all about operational fit for service in our climate, and also operational fit within transit agencies. It's also testing out safety protocols, operational experience, and really paving the way and opening the door for broader scale adoption of these types of vehicles. So moving on now, CP, I really like this project, and I really admire how CP is kind of taking the bull by the horns, charging ahead and becoming a leader in this space for locomotives. I like to think of it as sort of the ACE-Tech project on rails. It's quite similar. It's retrofitting an existing locomotive chassis with a hydrogen fuel cell electric powertrain, which in itself is a neat project. But a few important things here. I mean, number 1, it's a train, which is pretty interesting. I mean, who didn't like trains as a kid? But it's also really important because it's a locomotive, and locomotives consume large amounts of fuel. So that means a large demand for hydrogen. And if you recall, one of our goals and one of the key factors to unlocking a hydrogen economy is creating demand. The second thing that's really important about this project is that it's a line haul locomotive. So other locomotives that I know of, most of them focus on yard duty, things like switchers and shunting duty, which localizes the hydrogen demand to one spot, i.e. the yard. And this makes sense because it's easier to supply the hydrogen in those cases, easier to refuel. You can haul less hydrogen around. But this one is different because it's a line haul locomotive. And what that's really doing is CP is signaling intentions to move this train across the country, which is going to create demand in many locations, which helps unlock hydrogen economies in new and different regions. So number 5 is hydrogen diesel dual fuel. And I'll take a bit of an aside here, and I'll first explain what it is, but then I'll also explain why it's critically important. So when we talk about hydrogen diesel dual fuel, what we're really talking about is co-combusting hydrogen in the combustion chamber of a diesel engine. And I apologize if this is getting way too rabbit hole-y, but I am an engineer, so forgive me. So injecting hydrogen into the combustion chamber of a diesel engine. Now, this can be retrofitted existing diesel engines, or it can be brand new engines. There's a lot of technical hurdles that need to be overcome to do it, but we can, or not us, but the companies that are doing it can displace up to 40, 50, there's targets around 60% of the diesel that they can replace with hydrogen. So this is important, one, because it has immediate emissions reduction benefits for sure. It reduces particulate matter, it reduces NOx and SOx, it reduces the maintenance on particulate filters on trucks. But the second, probably more important aspect of it is that this is a low cost, low risk way to create hydrogen demand. So if you think of the contrast between a fuel cell electric vehicle, which has hydrogen as the only way to drive around, it's the only fuel, versus hydrogen diesel dual fuel, you have diesel on board and you have hydrogen on board as well. So if you run out of hydrogen, in the case of dual fuel, you can still drive to a diesel gas station and carry on your operations. If you run out of hydrogen in a fuel cell, you're stranded on the side of the road. So that sounds bad. That makes fuel cell trucks sound bad, and that's not true. Fuel cell trucks have a lot of advantages with drivetrain efficiencies, maintenance costs, et cetera, et cetera. But what you have to do is back that up one step and think about why did that truck run out of fuel? And the answer is the fueling infrastructure. So there's a real, with battery electric vehicles, everybody talks about range anxiety and not being able to find chargers. Well, it's the same thing with hydrogen. There's no hydrogen fueling infrastructure. So companies have a lot of anxiety adopting a hydrogen fuel cell truck. And even when they do, if there's fueling stations in Edmonton, Calgary, that still really limits the operational use of that truck, making this a high risk purchase for those companies. So what hydrogen diesel dual fuel does is it de-risks that adoption of hydrogen. So not only is it lower cost than a fuel cell truck, it's lower risk, which, as I mentioned before, it's not just about the economics, it's about the non-economic factors as well. So now trucking operators, they can reap the benefits of using hydrogen when it's available, the lower cost of hydrogen, the lower emissions, the lower maintenance, all that good stuff. But now if they have to make a trip sort of outside of that captive zone where hydrogen is available, they can still do it with the same asset, and it increases the flexibility of the asset. So low risk, low cost way to create demand for hydrogen. And even if you take that one step further in our modeling, what we've modeled out is two scenarios: one with hydrogen diesel dual fuel, and one with hydrogen fuel cells only. And by far, the lowest cost way to build out infrastructure for hydrogen fueling is by adopting hydrogen diesel dual fuel, because again, it's low cost. You can run out of hydrogen and you're fine. So you don't have to have as many hydrogen fueling stations. You can build hydrogen fueling stations at scale. Just many benefits. So what these funded, there's actually a number of funded projects. One is the University of Alberta is doing some sort of core research with Cummins to integrate the combustion of hydrogen in the chamber with the stock engine controller. But we also had a dual fuel commercialization program that was funded by Prairie's Economic Development Canada and run by our partners Foresight, which really tried to tease out technology commercialization companies to commercialize hydrogen diesel dual fuel technologies. So we say partially funded because we've come out of that program with a number of really promising technologies, and now we're looking at the next steps of deploying it into pilots so that we can get dual fuel diesel trucks on the road, start measuring the emissions, start measuring the environmental benefits, and start increasing awareness and adoption readiness of that technology. So I'll carry on. Some other projects that are on the go. Alberta Motor Transport Association is launching what we're calling a roadshow. And this is a project aimed almost exclusively at the non-economic barriers again. So it's about operational familiarity with fuel cell truck technology, how to integrate fleets at a larger scale into actual operations. And really it's the precursor to a full-blown commercial adoption program. And it's helping support the build out of hydrogen demand, and it's also helping incentivize supply. Part of this project is there's a fairly large data portion of it where the data from the project will help decision makers, whether it's carriers or government organizations. It'll help them with their investment decisions when considering adopting hydrogen vehicles, whether it's fuel cell or dual fuel. Hydrogen testing is a really important project as well. I mean, these are all important, I guess, but there's an entire set of technical challenges associated with hydrogen that needs to be addressed. They're not insurmountable, but they need time, effort, and resources to overcome them. And C4 Technologies is starting down this path with the support of the federal and provincial governments. And then carrying on, now there's a number of projects that are sort of in the more conceptual stages, feasibility stages. We're getting sort of further down that potential roadmap. We're exploring the feasibility of pure hydrogen in combined heat and power scenarios for net zero buildings that can support fueling for transit fleets or municipal fleets or even commercial fleets, non-municipally owned, anchored by rec centers or other large commercial and industrial type of buildings that have a hydrogen demand that we can turn into electricity and or heat. And then of course, fueling stations to support the mobility, the transportation projects. And then with the AMTA Roadshow kicking off, we really need to start thinking about how can we turn that into support for carriers in full commercial adoption. So we're starting to sort of conceptualize what this might look like. And there's a number of other, many other projects that are announced, and they can trace, a lot of them can trace their roots back to the hub through the hub directly, or hub activities or hub partners. Nikola TC Energy announced a partnership. ATCO and Suncor announced a production partnership. The Air Products announced a production. Even some of the export announcements like Mitsubishi, Shell, Petronas, and Itochu. Lots and lots of activity in the region, and all of it is needed, I would say. So finally, what I'll touch on is what we're up to next. We've identified some next steps, but keep in mind, we do keep our plans nimble, and we try and maintain that so that we can be able to respond to the ever-changing economic conditions. But we do plan on some more webinars. We have a tentative forward plan. It is posted on our website. We are being flexible on topics and speakers so that we can stay relevant. The best place will be, again, our website, subscribe to our social media, etc. Next, we are continuing engagement. We're doing this through workshops and working groups, but we're also starting to focus on ways to engage senior leaders across the value chain to advance investments and co-develop this implementation pathway that I gave you a little bit of a sneak preview on. Also look for a strong presence from the hub at the upcoming Hydrogen April convention. This is becoming quite a large all of value chain event, I like to think of it. And we do have a number of techno-economic analyses, a forward-looking list as well, but again, subject to change based on strategic importance. So this is what you can expect from us in 2022. And finally, I'll close with this. I'll say that there's this clear, remarkable, and structural advantage to developing a hydrogen economy in the Edmonton region. There's years of experience, years of industry expertise. There's a number of motivated companies. There's years of experience in constructing and operating assets at scale, producing hydrogen, capturing carbon at scale, sequestering CO2 at scale. That experience moves around the workforce. So it's not just in the companies that are owning and operating these assets. There's a large pool of skilled engineers that have experience in this area. So there is this huge opportunity to make some significant advancements. And arguably, this is the lowest risk place in the world to invest in taking these first steps down a hydrogen pathway, or down a pathway to a hydrogen economy. And really by doing so, we can build momentum, build the knowledge and the know-how, and then quickly link to other regions to unlock the true potential of a Canada-wide economy. And the reason that's important is, again, back to the idea of having a captive fleet. If you have a fleet of vehicles that are stationed in Edmonton, but you have to deliver goods to Toronto, if there's no hydrogen along that route, then you're really limiting the potential of hydrogen in the Edmonton region. And the same with the CP rail. I mean, if it's a long haul locomotive, it doesn't have far to go if it's only going from Calgary to Edmonton, or it's going from Edmonton out and back to refuel in Edmonton. So really it is critical that we develop a hydrogen across Canada, a hydrogen economy across Canada. And Edmonton is the best place to start. It's the old adage of, how do you eat an elephant, right? You have to take your first bite somewhere. So the best place is here. So with that, I'll stop and turn it over to David. He can check the chat and the Q&A and open it up for discussion.
Great, thank you very much, Mark. We are, what I'd like to do is we're going to pick on a few of the questions, but I'd like to start off with one is, maybe there's been a lot of interest in launching hubs or hydrogen centers across Canada. Maybe you could just talk a little bit about the process that was used to get the Edmonton Hydrogen Hub off the ground.
Yeah, sure. Thanks, David. So there's two really big factors, I would say, sort of looking back now in retrospect. And one of them was leadership. So visionary leadership from, well, people like you, Dr. Lazell, for, quite frankly, but the leadership around the table of the municipalities, the mayors at the time, Mayor Iverson, now Mayor Sohi, the Mayor Nachu, and the other regional mayors and the chiefs of the region that actually said, hey, look, there's a real opportunity here. We want to do something about that. So that's sort of number one is the leadership and somebody willing to do something. But number two was the analysis of the region, the regional potential, the production, the assets, and really granularly quantifying sort of what that scale is. And that was done in, as you know, the Hydrogen Task Force, or the Alberta Industrial Heartland Hydrogen Task Force, and those reports were released in late 2020. And having been working on this for the past year and a bit now, I can say, from the bottom of my heart, how important those are to have that sort of foundational knowledge and that foundational study, because I still refer back to those reports. I look back at the references, I look back at quantities, I look back at it to sort of check analyses and make sure we're sort of in the same scope and scale. They're really, really incredibly valuable resources.
Great, thanks, Mark. We have a question from one of the attendees about how can private organizations that are not involved get involved within the hub? What are your recommendations?
You know what? That's a great question, and we get that a lot. I get that a lot for sure. So number one is this, attending webinars. Hopefully, this kind of gets some of your creative juices going, and shows you kind of where we're at. But again, number two, it comes down to the leadership. Where can your private company, as a private company, where can you think you can get involved? And there are lots of private companies involved. I mean, you saw a lot of logos on some of those projects. Bison, Trimac, those are private companies that are involved in the Aztec project. Suncor is a private company involved in that project. So if you have ways to sort of plug into some of these needs, if you have projects that you can launch, if you have a network that you can leverage, if you have capital you can invest, these are all types of ways to sort of harness the creativity of that private sector.
Great, thank you. We have a question from Robert Bott, who's asking, are we working with other hubs such as Prince George, Regina, Sarnia? There's also a desire to set up hubs in Vancouver, Hamilton. I was wondering if you could just talk about other initiatives across Canada and maybe what the opportunities are to link to what we're doing in the Edmonton region.
Yes, for sure. So as far as I know, those regions are at the sort of foundational report stage. So we are in discussions with a lot of those organizations. Maybe I'll jump to what the end state is that we see as really important. So the end state, my last slide, was all these hubs that are linked, quote unquote. But so what does linked mean? So really that means a way to share information about projects, about activities, connecting organizations, understanding what the demand is in the respective areas. And just to give you an example, like if we end up having a fleet of 200 trucks in Edmonton that are hydrogen fuel cell, they're going to want to know where they can get hydrogen, right? So that's the importance of connecting that information to other hubs. I can say, a lot of the activity that we've heard of, so Calgary and Southeast Alberta are going down that road to do this foundation study to understand supply and demand scenarios in the region. Saskatchewan is looking at it, Manitoba is looking at it. We've had talks with Prince George and Vancouver as well. So there is a lot of interest and a lot of activity. I'll say that as far as we know, nobody's at that point of having kind of a structure figured out, and nobody's operationalized it yet as a hub. So what we're really trying to do is help lend our experience and provide structure and help from our black eyes and what we've learned over the past year and a bit.
Do you see any signals of federal government coming through with some dollars to help in hubs? Or I know we're got our fingers crossed on that, but there any?
Well, so I mean, the national hydrogen strategy points to hubs as very important. There's the Hydrogen Hub working group that has been up and running sort of since the launch of that federal strategy. There's, I don't know if we're allowed to talk about rumors, but there's hopefully rumors that there's going to be funding for hubs across Canada potentially soon in the next federal budget. But you know, ideally it would be sort of a coordinated effort where the hubs are they're not done ad hoc. They're done sort of intentionally.
Right.
You know?
Thank you. How would you say hydrogen blending is a good solution to address stranded assets due to electrification? Or there's a question there. I think the way I would interpret that is that if you have excess electricity, maybe making hydrogen and putting it into a hydrogen blending project. Is that? I'm trying to understand that question. I think that's.
Yeah. So I would almost understand that as, okay, so we can sort of play with that angle, but the other angle is possibly if natural gas is no longer being used and everything is electrified, then there's going to be a bunch of stranded natural gas assets. So that's maybe the other approach, whereas blending hydrogen is a possible way to continue to use those assets. So my approach to both, and our approach to both, I think, would be to look at the economics, right? So many of these things are really regionally specific and case by case specific. And what are the economics of? So in the case of having an electric asset that, you know, isn't grid connected or doesn't have a robust grid connection, if you have excess electricity, what does it cost to turn that into hydrogen and blend it into a natural gas utility system versus, you know, what's the price you get back for that hydrogen versus the cost of just letting that asset sit idle. The same would be for stranded assets for natural gas. What's the cost of abandoning a natural gas pipeline, whether it's distribution or transmission, and installing a new electricity transmission line? Because if you're taking one energy system away, you have to replace it with another. What's the cost benefit of doing that? What's the GHG dollars per ton of reduction of CO2? Those would have to be, I think, analyzed on a case by case basis. You know, one thing, just to sort of go off on a tangent on that, one of the things that you see articles published and reports released, they want to make these blanket statements about this is good or this is bad, blending is good, blending is bad, right? You can't really do that in this transition because so much of it is case by case and there's so much uncertainty in it. I understand people's need and desire to get rules of thumbs in place quickly, but we're not going to have rules of thumb that are credible for another 10, 15 years, I would say. So it's really dangerous to say, is this good or is this bad type of thing.
There's a question here. You talked a bit about pipeline infrastructure and other infrastructure. There's a question from Derek McLean. For pipeline and infrastructure construction companies, what are the challenges that you foresee in building out this hydrogen economy? So I think specifically looking at pipelines and other infrastructure that has to be put in to connect supply to demand, for example.
For sure. So there's a lot of challenges. Pipelines are interesting in that they're quite well understood, and most of the challenges are economic. But when it comes to repurposing pipelines or even understanding what a low-cost pipeline would look like, we're into a little bit of unknown territory with hydrogen. So this is a little bit of what CFR is working on, is trying to characterize materials that are compatible with hydrogen. So there's a little bit of uncertainty around pipeline materials and allowable pressures of hydrogen and things like that. So really it comes down to finding what is the best, most economic technology. Now, some ways to repurpose pipelines, for example, are running liners through them, whether it's a coated steel or low carbon steel or plastic liners or fiber reinforced plastic liners. There's new technologies out there to monitor using fiber optics. You can monitor for leaks. You can monitor for lots of different things with these new technologies. So this is the area of opportunity. Whenever we're in a disruption like this, there's always opportunity for creative companies.
Excellent. And that picks up an answer to another question we had lower down on the list, but I've got another one I hope we get in the last 3 minutes. What is your, this is from Mark Lowy. What's your response to critics who say that we should bypass blue hydrogen, in other words, hydrogen made from natural gas altogether, because it will result in more fossil fuel natural gas production, and instead just go directly to green hydrogen production?
You know, that is a great question. And again, one that we get all the time, quite often. And I kind of answered it with the rules of thumb, sort of when I was ranting about that. You can't just say green is good and blue is bad, because the one thing that blue hydrogen does, if done right, is offers us a pathway to this transition that's affordable now, that's the technology's available now, it's ready now. I mean, there's challenges that people like to pick on with blue hydrogen. We definitely need to consider upstream methane emissions. Those need to be accounted for. They need to be, it needs to be transparent. It needs to be reduced, right? But really, it comes down to the economics of, if we just look at carbon intensity and cost, those are the two parameters that we really should look at. And if blue hydrogen or turquoise hydrogen or whatever color hydrogen you can think of, if it meets those parameters, the carbon intensity that we need at the cost that we need, shouldn't really matter how it's produced. I mean, it's not producing fossil fuels isn't necessarily a bad thing. It's when you combust them and turn them into CO2 that it becomes a bad thing, and the fugitive emissions during the production. But if those are all sort of contained and the carbon intensity meets the thresholds, and while doing that, you meet the economic thresholds, it shouldn't be an either or question. It should be an and with, and there's going to be applications for many methods of hydrogen production.
Okay, we got 30 seconds left. Can you tell us when we're going to see the first public hydrogen fueling station within the province, and maybe the first hydrogen trucks on the road, or hydrogen trucks or buses on the road, or trains?
Sure. So we have this summer, we should see a lot of activity. I'll leave it sort of vague like that, that we should have some or many of the above, and we'll leave it as a teaser. Maybe keep your eyes and ears open. Think about attending that April hydrogen convention, and hope to see you there.
Thank you very much, Mark, and thanks to everybody who's been here. If we will maybe try to see if we can answer your questions individually, or back and send emails back to those who've asked questions that we haven't been able to get to. Thank you very much for the presentation today, and thanks to all for the participants and for the great questions. Thank you.
Thanks, everyone.